Great. Thank you so much, Michael, for the introduction, and thank you all for welcoming me here today. I just wanted to start off and mention that I live and work and raise my children on Treaty 13, and it's the traditional lands of many First Nations, including the Mississauga of the Credit. And I'm just overwhelmed by the welcoming support in welcoming me here to Thunder Bay over the last few days, so thank you very much. As mentioned, my name is Veronica Madonna. I'm an architect that practices in both Ontario and Manitoba. And I'm the founder of my firm, Studio VMA. And it's an architectural practice that is working to apply concepts in low carbon design, mass timber design, towards a sustainable and healthy future. I'm just gonna see if I can lower that a little bit. There we go. Today I wanted to share this study that we had done with an incredible team, including the Thunder Bay Community Economic Development Committee and the Center for Research and Innovation in Bioeconomy, also known as CRIBE, in order to look at the benefits of mass timber workforce communities. So thank you very much to both of them for giving me this opportunity to study this very important topic, one that kind of involves aspects of community health, thinking about low carbon design and utilizing our forestry products to kind of really stimulate bioeconomy in the advantages that it has. We developed this study with an excellent team, including Element 5, which is Ontario's first mass timber fabricator, which is located in St. Thomas. Also Introba, which is a leading sustainable mechanical electrical engineering firm. Hanscombe, who prepared costing analysis for this report, and the Ontario Woodworks. So the study looked at a number of different aspects, and one of the things that we did is we developed prototype building designs in order to study the carbon and health benefits in thinking about mass timber structures for workforce communities and mining communities. And one of the key aspects of the design also included off-site prefabrication and some of the challenges and innovations that would result. We did a thorough embodied carbon analysis as well as a costing analysis to understand the impacts in terms of economics of the project. So the study was in response to an imminent surge in mineral and exploration and processing of the north, which is why we're all here. And the objective of the study was to employ mass timber, in particular focus across laminated timber structure, as a solution for infrastructure to deal with some of the challenges that northern communities face with developments of buildings. The core values that drove the design development included encouraging health and wellness to support employment retention, as well as the well-being of workers, addressing the climate emergency, so thinking about how do we design and build for low carbon, building upon Canadian traditions and values, coming back and rediscovering the opportunities of wood construction, and thinking about long-term durability and value that these structures could provide for years to come, even after the use of the building is done with. And then also strengthening Northern Ontario's bioeconomy. So the study looked at and was response to several critical challenges that workforce mining camps and communities face, including the remote location of the communities, as well as sometimes harsh weather conditions. And these all play a role in terms of construction of infrastructure, workforce accommodation and mental health and wellness aspects, considering the health and wellness of people who are working in the community and using natural materials within their living and working spaces, as well as work-life balance and thinking about infrastructural needs. Mass timber had several advantages and opportunities, including climate mitigation for low carbon processes in the making of the mass timber, construction speed and efficiency, and its durability and long-term advantages of the structures. So just to start, maybe I'll just kind of take a moment to explain mass timber in itself. Mass timber is a little different than the conventional stick frame wood construction that you would think of. It is comprised of laminating like 2x4s, 2x6 products together to make massive sections of wood. And what this really does is that it creates an exceptionally strong and versatile material that could be used for structural supports, could be used for structural walls, it could be used for beams and columns. It has inherent fire-resistant qualities, and it has, aesthetic and comforting qualities, especially when it's in an exposed situation. As I mentioned, it's very durable, and it kind of leads into prefabricated construction methodologies, which also results in speed of construction and durable kind of aspects. So Canada is a leader in mass timber construction. It is not a new technology. It's been occurring around the world for many years now. And in fact, I think the latest report suggests that we have over 760 mass timber buildings and projects happening or built in Canada. And other provinces like British Columbia have a wood first program, which really encourages the use of wood and mass timber as the first option in construction. And oftentimes in many buildings, mass timber can replace the use of concrete and steel. This is just an image of a prefabricated cross-laminated timber structure that is made in a shop and then transported to site. So we began the conversation in the study with a discussion rooted in biophilic design. And biophilic design literally means the love of living things. And biophilic literally, let me see, okay, great. So biophilic design states that connecting humans to the natural world can significantly influence and reduce blood pressure, it can reduce stress, it can increase productivity. And these are studies that are happening around the world now to really kind of understand what the advantages of being and living in natural environments, living with natural materials, and biophilic quality of design. And as Canadians, we spend nearly 90% of our time indoors, so thinking about indoor quality is really important and ultimately leads to the health and retention of people in communities. Natural materials and biophilic design also is proven to increase productivity. So in office environments, for example, people are known to call in sick less, and they're more happier and have more productivity. So there's lots of great advantages to live and work in wood buildings. Also, one of the considerations that we always think about is that the regulations that are occurring around the world and are starting to kind of be seen in Canada, there's a need to have action against reducing carbon. And so thinking about how can we reduce carbon in our buildings is a really important topic, and thinking about the embodied carbon of our buildings is an important topic. So this is just an image I wanted to throw in to show the prefabricated structure kind of lifting into place. And this is similar to how we approach the prototype design of the modular buildings. So I'm just going to walk through the design itself and how we approached it and some of the benefits that we found from the study. So first of all, our site was really kind of speculative. It was undefined, but we knew that it would be in the northwest Ontario region, so north of Thunder Bay, and so that was the kind of area that we looked at in terms of the design of the project. When we started the design, we considered a number of different construction techniques and methodologies, and we quickly eliminated site construction because of remote possibilities of the site. And so having materials brought and built on site wasn't really kind of realistic. We looked at 2D elemental fabrication, which meant that components like walls, beams, columns would be brought separate to site. But then again, it also required a level of assembly on site. And so we really wanted to kind of push the ideas of off-site prefabrication of the buildings where they would be completely fabricated in a factory, perhaps in Thunder Bay, and then they would be shipped to site and connected together in very quick speeds of time. The program that we utilized included an occupancy of about 250 people to start. We had living quarters, we had community buildings like dining halls, dry houses. We also had a office building scenario where we developed prototype plans for that are included in the report. And for the living quarter in particular, this was about 80% of the site, so this is where we focused a lot of our attention. We understood that the site would have maybe about 250 people to start, and then perhaps within 2 to 5 years, once the mine is built and is moving into operation, there would be about 100 people moving forward. And so what this meant to us is that we needed a solution that was scalable, where the buildings could be unplugged, moved when the time is needed, when they weren't in use anymore, and they could be reused, perhaps sold or reused for another mine. And I think there's a conversation there about long-term durability. We also included in the design of the living quarters an Arctic corridor that would connect the living quarters together. And one of the things that was expressed was perhaps having an outdoor area for the workers, like a porch, would be something that would be a value add to consider retention and health and wellness of workers. One of the things that we really wanted to address was energy performance of the buildings, and right now the building codes do not require minimum energy requirements for temporary workforce housing. And although it's not technically required, we wanted to push the boundaries and think about how do we provide a high-performing thermal performance building, not only to reduce energy over time, in terms of the operation of these buildings, but also to think about the thermal comfort of people living and working in these buildings. So in our design, we designed for very high thermal performance of the walls, ceilings, and roofs, which later you could see, I'll show you what the carbon kind of outputs of that were. In the prototype design, we designed a series of modules that basically are a kit of parts where you can pick and choose the different components and you can connect them together on site. So for instance, if you would like to create a recreational facility, you can pick and choose the components that would work for you and connect them on site. And so that there was a modularity and repeatability aspect, which also comes down to the economics of the units as well. This slide and the next slide will just show you the sequencing of how these structures would be fabricated. We imagined that the cross-laminated timber slabs about 15 meters by 3 meters would be brought to a facility, perhaps in Thunder Bay, where they could be manufactured, dressed and with the connectors, and then they would be made into the buildings. They would be shipped, complete buildings would be shipped from the factory to the site where they would be assembled depending on their arrangement. They would be connected with an Arctic corridor. They would run services, perhaps add the outdoor porch, solar panels, whatever the additional elements that was needed. And then at the end of its use, they would be unplugged and moved so that there was a ability to reuse these structures over and over again. And one of the key aspects of mass timbers is that it's a very robust and durable material that can withstand the lifting and shipping multiple times. So that's a key aspect of this project is that while traditional buildings that might be used might have a lifespan of about 10 to 15 years, these buildings would be 30 plus years. So at the end, you would have an asset at hand. The logistical, I see I'm almost out of time here. The logistical framework was very important in terms of moving of the structures. So what we did is we started with the maximum size, and we kind of had a little bit of a consideration between optimizing the cross-laminated timber structure as well as the shipping aspect. So we used one slab of cross-laminated timber for the floor, for the roof, for the walls, and then lightweight frame construction in between the units in order to achieve acoustical properties. There is a high-performing envelope, and I just want to move to this slide. So the units themselves would be clustered together, and the services would be provided through an Arctic corridor, and at the end of its use, they could be disattached and moved again. So again, it was a bit of a plug-and-play scenario where you didn't have to modify the properties of the units themselves by moving them around. This just is a view of a single unit, although for the sites we imagined that the units would be clustered in clusters of 6, and then they would be separated by a fire separation and clustered again, and this would be optimize the servicing of the site. This is a view just looking down the internal street of these corridors, and really what this shows is that, you know, the kind of community aspect that can be created by thinking about the structures and thinking about the architecture and using materials like wood to kind of really benefit from creating a community feel. This is a view of one of the interior units where what we see here is we tried to leave exposed the mass timber as much as possible to take advantage of those biophilic qualities that I had spoke about before. They're very compact units. Each unit has an ensuite washroom, and each module contains about 3 units in themselves. So just to conclude, I wanted to just walk through the embodied carbon kind of analysis, and just to state that, well, first of all, the life cycle assessment embodied carbon looks at carbon through the production of the materials and the construction processes. A little different than operational carbon, which looks at how much carbon is used when the building is in operation. And so when you think of life cycle assessment, you think about when the material is extracted, you think about when the material is being built, when it's being maintained, and when it's being disassembled for end of life. And so this is a calculation we did. Now, what's interesting is that, okay, I just wanted to make sure. The blue is representing the mass timber structure, and the orange is a traditional building component that you might see in a mining community for a one living quarter. And you can see that they're pretty comparative in terms of embodied carbon, but in fact, it's not really an apples to apples comparison, because the blue, which is the mass timber building, actually has a very high performing envelope, which means it has increased insulation. And insulation right now in the products we have available to use is actually is high embodied carbon. So it's not quite an apples to apples comparison, but when you think about the durability and lifespan of the structures, the mass timber structure would last 30 plus years. And the traditional structures last about 15 years, we kind of assumed. And so you can imagine that there's a double of carbon over time. Those are just metrics. We also did a costing analysis that's in the report, which is available. I'm not going to go through the numbers just right now, but just for the sake of time, but it is there and available to understand the cost differences. We did a capital cost and also a rental option for that. And, you know, I think just in terms of the advantages of mass timber, there were a lot of considerations that we thought of and kind of concluded. And long-term durability and maintenance was a key in that, you know, these buildings will be robust and could be used over and over again and could be assets at the end of their use. Health and wellness for retention, and also thinking about efficiencies. So thank you very much. Sorry for going over time.